This photo show you how you extract salt from the soil. This prepare a soil-based. This called soil-based extract. You put the soil, the water to the soil until the mixture shine on the light and have this shape. Let it overnight, and if it is dry, add more water, and if excess water on the surface found, then add more soil, and then you have to go to the suction pump here. The suction is suck the air here, and consequently the outer pressure will be more than the empty one inside the beaker, because there is a suction pump here. So maybe this clearer. The suction suck the air, and consequently the pressure inside the beaker be lower than outside, and then the atmospheric pressure will be led to the water to the extract to be drained away from the soil. Another type of suction pump to extract the water, soluble water extract from the soil. You can also make a soil water extract 1 to 2.5, or 1 to 5, or 1 to 10. 1 gram to 10 milli water. So it means that 1 to 10 means that 10 gram of water to 100 milli of 10 gram of soil to 100 milli of water, and you can shake and make filtration directly. Take this filtrate and measure the EC. How you measure the EC? There is an apparatus called EC meter. This is an EC meter. The EC meter based on has two electrodes, cathode and anode, and a battery, a source of electric current. The higher the soluble salt, the higher the soluble salt, the higher conductivity found. So there is a direct relation between the soluble salt concentration and the electric conductivity, as I told you. Here, if you look here, this is the electrode. This electrode contain cathode and anode, and they can convert the reading directly to this is Siemens per meter or millimoles per centimeter. Another type, you can find also a portable EC like this. You can take it to the field and measure the electric conductivity of the water directly, but the soil you need to make the extract before measuring its EC. So usually the EC measured on the lab. However, you can measure the water or groundwater on the field using this portable EC. Look to this electrode. It looks like the EC electrode. However, its inside differ because it has it's a pH electrode, has a glass membrane here, and its mechanism differ from the EC electrode, but because it has a reference electrode and an electrode sensitive to the pH activity. No problem, just to know that there is two two apparatus generally used for measuring AC and pH. The first is AC meter and the second is pH meter. Both have same shape, however, the electrode of pH differ from the AC electrode. But maybe you can find an apparatus or an electrode has both AC and pH, can measure pH and AC, has this both electrode on one electrode. So one electrode, just immerse one electrode to the extract, you get the reading of AC and pH. What I want you from this previous apparatus, just to know that the EC meter is used for measuring the electric conductivity of the soil, which represents the salinity, and pH meter is used for measuring the pH, the soil pH. Also, I want you to know that there is different type of extract. There is a soil-based extract which is more accurate for measuring the salinity, but it needs a suction pump. However, you can make a very quick test for measuring salinity by making extract, shaking, and then filter. Take filtrate and measure the AC directly by AC meter. So we have different type of soil extract, soil-based and soil extract, and AC meter for measuring AC or electrical conductivity of the soil. pH meter is used for measuring the pH, soil pH. You can immerse the electrode of pH directly here to this suspension and measure its pH, because the pH may be increase or decrease according to the condition, the outer condition. For example, if you let these extract for longer time, the carbon dioxide will be dissolved and cause carbonic acid, which may be to decrease its pH. So the pH should be measured directly after finishing or before making filtration. You can immerse the electrode directly to this suspension. And then make filtration and measure the EC after that. So the first step, measure the pH on the suspension, and then make filtration and measure the EC of the extract. Some people said that there is on a pH electrode there is a KCl here, may increase the electrical conductivity. Consequently, they prefer to measure the EC first and then measure the pH. If you prepare already the extract, you can measure the EC and then the pH. Saline soil. Saline soil is usually defined as a soil where the electrical conductivity of the saturated soil extract is greater. You know the meaning of saturated soil extract now. This called saturated soil extract. This called saturated soil based and when be extracted called saturated soil based extract. So if the soil based extract is greater than 4 decisiemens, you measure the extract and found it by AC meter, its electrical conductivity is more than 4 decisiemens per meter, then it can be considered as saline soil. Some scientists have suggested that the limit of saline is 2 decisiemens for saturated soil based extract. Why? Because many crops, especially fruit and flowers crops, can be affected by salinity in range of 2 to 4 dc per meter. This photo of a salt affected soil. Look, here is the salt accumulated on the surface of the soil. Sodic soil. What's the meaning of sodic soil? I told you sodic soil that contain exchangeable sodium percentage or ESB or and sodium absorption ratio SAR is more than here 15 and where there is 13. What's the meaning of ESB? Exchangeable sodium percent is the amount of absorbed sodium or exchanged sodium on the soil exchange complex, expressed in percent of the cation exchange capacity in milli equivalent per liter per 100 gram of soil. So if you ASB equal exchangeable sodium, you have on the exchange on the particles there is exchangeable sites. All exchangeable sites called cation exchange capacity. While if you measure the exchanged sodium only and divided it in cation exchange capacity, multiply 10, you will get exchangeable sodium percent. So exchangeable sodium percent milli equivalent per 100 gram over cation exchange capacity milli equivalent per 100 gram of soil multiply 100, you will obtain exchangeable sodium percent. If a question here, calculate a problem here, calculate ESB of the soil, have CEC 50 milli equivalent per 100 gram soil and exchangeable sodium percent 10 gram. It's easy, 10 over 50 multiply 100 equal 25%. This soil is considered sodic soil. Why? Because ESB more than 15. If the ESB is more than 15, the soil is considered, if it is more 15, the soil considered sodic, while if it is less than 15, ESB, if it is less than 15, it is considered non-sodic soil. Another parameter can be also used with previous or instead of previous, called for demonstrating the soil if it is sodic or not. This parameter called sodium absorption ratio, SAR. The sodium absorption ratio is measured of the amount of sodium, Na, relative to calcium and magnesium in water extract from the saturated soil based in unit milli equivalent per liter. ESB, you measure the exchangeable sodium on the particle and ZEC on the particle, and I do not explain how we measure it on the lab because it is more complicated than making soil based extract. So ESB is exchangeable, the cation exchanged on the soil particle. However, SAR, you make the saturated soil based extract as I demonstrated here. Make a saturated soil based extraction and then measure sodium, magnesium, potassium, and then use the following equation. This SAR equals sodium over the root of calcium plus magnesium over 2. If you make this calculation and found the SAR less than 13, the soil is then non-sodic soil. However, if the SAR is more than 13, the soil is considered sodic soil. Okay. Calculate the SAR if the concentration of all of these elements